Okay, so today we're going to talk about irrational square roots. Last time we talked about rational square roots. You guys remember what rational square roots were? Somebody give me an example of rational square roots. Square root of, yes? 4. Because that will get you a number like 2. Square root of 4 is 2. Why is 2 a rational number? Because you could write 2 as 2 over 1. So whenever you could write something as a fraction, right, then it's called a rational number. So guess what irrational square roots are? First of all, what do you think irrational numbers are? Forget about square roots for now. What do you think if the rational numbers were numbers you could write as a fraction? What are irrational numbers? Numbers that you can what? Yeah, you can write as a fraction. So write this down. I'm gonna first tell you before we talk about irrational square roots. Let me tell you what irrational numbers are. So irrational numbers are numbers that, of course, you cannot write as. It says are real numbers that cannot be expressed in the form of a over b. And another way of saying is you can't write as a fraction. Okay. And I said b can't be 0 because, of course, you get undefined number. So this is another way of saying numbers that you cannot write as a fraction, a little bit more formal. Irrational numbers are real numbers that cannot be expressed in the form of a over b, where a and b are integers. Okay. And b can't be 0. Some examples here. We talked about this before, like pi, square root of 2, square root of 3. How come I didn't write square root of 4? Square root of 4 is what? Yeah, square root of 4 is 2. So that's why. So these square roots, you know. So we sort of talked about this last time. So these are some numbers that you cannot write as fractions. Okay. And there are infinitely many of these. Okay. So I highlighted these square roots. Guess what these square roots are called? Square root of 2, square root of 3, negative square root of 10. Not square root of 4, right? That's guess what these are called? Look at our, yes, irrational square roots. Okay, so these are irrational square roots. That's what we're talking about today. Last time, we only talked about rational square roots, right? Square root of some perfect squares, right? It became some rational number. Now, we're going to learn and how to deal with irrational square roots. Mainly how to simplify it and things like that, okay? So that's why I highlighted these. These are irrational square roots. Square roots that you cannot write as a fraction, right? It's unlike the rational square roots where you have square root of a perfect square, these are, of course, not perfect squares. Okay? All right, so how do we simplify these things or deal with these things? Okay, irrational square roots. So that's what we're going to learn today, okay? All right, so the question was, do you have to have square root of a prime number? Yes, if you have a square root of a prime number, it's always going to be irrational, but they don't necessarily have to be. Like square root of 10. 10 is not a prime number, still irrational square root. Okay? All right, so in order to simplify these irrational square roots, we need to remember some of the rules we learned for square roots. Do you guys remember first rule we learned? Square root of AB was square root of A times square root of B, right? Also, square root of A over B was simply square root of A over square root of A over square root of B. You guys remember that? Yeah? Okay. And so, knowing these rules, we could actually simplify these irrational square roots. Okay, so some of these irrational square roots, you cannot leave it as it is because it's not simplified. So we'll tell you how to simplify these in a minute. Okay, so remember these rules. We're going to use these rules to simplify. Okay. Write this last one. Whenever you simplify square roots, I'm adding this now because these are just rules for square roots, right? But whenever you simplify square roots, you may not have square roots on the denominator. Okay. But you may say, well, look at rule 2. You got a square root on the denominator, right? Well, we'll deal with that later, how to get rid of that. But whenever you simplify square roots, please keep in mind, you may not have square roots on the denominator. You have to get rid of it. And there's a simple, nice way to get rid of square roots on the denominator you'll learn today. Okay, so write that down. That's one thing that you got to be mindful of whenever you're simplifying. Okay, so write that down. No square roots on the denominator when simplifying. Okay, you cannot have square roots on the denominator. All right, so let's do some examples. It says simplify square roots, and of course, we're going to give you irrational ones now, okay? Because before we gave you where the radicand is a perfect square. Now, the radicand is not a perfect square. 216 is not a perfect square. So how do we deal with something like this? Some of you were asking me this, right? Remember when we were talking about rational square roots, right? What if you don't have perfect square as a radicand? What do you do? Well, here's what you do. First, just like before, you're going to do what? factor tree, because we want to see all the factors. So everybody go ahead and do factor tree for 216. Okay, I'll wait. Okay, we should all get the same factors, right? The tree doesn't have to look the same, but okay, go ahead. Everybody try to do a factor tree on 216. Okay. So how many people got something like this? I did mine here. How many 2s did you get, guys? 3. How many 3s did you get? 3. That's what I got too. So what do we do with it? It's not a perfect square anymore. When before you had a perfect square, everything worked out nicely. You get a rational number. Here, so what you're going to do is you're going to do the best you can to pair them up. And whatever that's left over, you leave it in the square root. Here's what I mean. This is what I mean by this. I'm going to gather the ones. So since I have 3 2s and 3 factors of 3s, I'm going to pair them up just like before. 2 to the second power and then square root of 2. 3 to the second power, square root of 3. Because what can I do with the square root and the square? I could cancel out, right? Do you see why I didn't write as 2 to the third, 3 to the third? Because if I do that, then I can't cancel it out, right? But if I write it this way, square root of 2, right, of 2 squared times square root of 2, square root of 3 to the second power times square root of 3. These cancel out. So what we know, what this is simply 2. What does square root of 2 become? Square root of 2 is just square root of 2. What about square root of 3 squared? What does that become? 3. What about square root of 3? Square root of 3 is just square root of 3. So that's what we get. Now, do you think this is the simplest way to write? No. Between all these numbers, right? Between all these expressions, there is zero multiplication, right? There is no multiplication. It means 2 times we had square root of 2 times 3 times square root of 3. So what can I write? Anybody see what I could do to simplify? Jonathan?
6 rad 2 rad 3.
Yeah, I could write 6 rad 2 rad 3. Do you think this is good enough to write? Yes. Okay, but what do we know about square root of 2 and square root of 3? Remember the first rule? We could go backwards now because none of these are perfect squares. Guess what? Instead of writing square root of 2 times square root of 3, guess what we could write? Amy?
6 times the square root of 6.
Exactly. We could just write 6 times. Square root of 2 times square root of 3 is simply square root of 6. So this is how you simplify. Okay. A lot of people are asking, what do we do with these square roots when you don't have a perfect square? As a radicand, this is what you do. Okay. So you just get as much as you get all the perfect squares as a factor, then you factor it out, not factor it, you simplify, and then you leave the the ones that are left in the square root, and then simplify, multiply it out. Okay, so you get an irrational number, right? You get an irrational square root. Does this make sense? Okay. This time it doesn't become a rational number because you have something left over inside the square root after you get all the perfect squares, right? Basically, that's what we did. Okay, do you get the idea? So is this pretty much similar to what we did last time? Yeah, except it doesn't become a rational number; it's an irrational number. Okay. Let's do some more. Okay, let's do some examples. Okay, this time I have 3 times square root of 125. So what do we do with that 3? What does that 3 in front of the square root of 125 telling you to do? Yeah. Yeah, just keep it there. But what is this 3 doing to the square root? It is multiplying, right? So you could just multiply whatever you get. So all you have to do is really simplify the square root of 125, and then if you get a perfect square as a factor, you could simplify that and then multiply that by 3. Anyway, go ahead. So what are we going to do first? We're going to do a factor tree for 125. Go ahead, everybody try. And see if you can simplify this whole thing. Okay. Go ahead, everybody try. I'll wait. Alright, so when you do a factor tree, did you all get 5 times 5 times 5? In there, is that what you get? Okay, so the next step then is, some of you are absent on 11.3, but we're going to pair them up. So instead of writing 5 to the third power in there, we're going to write 5 to the second power times 5 to the third power. 5 to the second power times 5. But everything is square roots. So we're going to write it this way. Does that make sense? Can we do this? Now in there, square root and the squares, they cancel out. So guess what we get? Square root of 5 squared, that's simply 5. So you get 3 times 5 times square root of 5. Square root of 5 is square root of 5. So that's what you get. And do you see how this becomes what class? What did you get as your answer? 15. Square root of 5. Right? Does that make sense? Okay. Easy enough? Alright, good. Alright, let's try one more interesting one. Negative square root of 1920. 1920. Go ahead, everybody try. I'll wait for you. Yeah, don't forget the negative. It's a negative number. So at the end, it's going to be negative once you simplify. Okay. All right. So you should have all gotten something like this. 1, 9. How many 2s did you get? 7. I got 1. So did you all circle your leaves? Especially when you get like tree that's this big, you want to circle your leaves because you don't want to mess up, right? So I got 1, 2, 3, 4, 5, 6, 7. Yeah, I got 7 factors of 2. How many 3s did you get? 1. How many 5s? 1. That's all you get, right? So did you all pair them up like this? Since you get 7 2s, I got negative. Remember, this is a negative number, right? So negative of 2 to the second, 3 of those with square roots, and then square root of 2, square root of 3, square root of 5. How many got this so far? Okay, if you got this, then you should have all gotten the right answer, because what's square root of 2 squared? 2. So you get 2 times 2 times 2, don't you? What's 2 times 2 times 2? Is it 6 or 8? Okay, it's 8. It's not 6. You don't add. You're multiplying all these, right? So you get 6 times square root of 2 times square root of 3 times square root of 5. So when you multiply these, you can simplify this, can't you? What do you get when you do square root of 2 times square root of 3 times square root of 5? It's simply, yeah, 30. You just multiply the thing inside. And the answer should have been negative 8 square root of 30. How many people got negative 8 square root of 30? Does this make sense?
Yes.
Okay. Do you see how to simplify these square roots? Even if the radicand is this big, right? You just do a factor tree, right? And then you gather all the perfect squares together and so forth, and simplify. Okay. All right. Let's move on to the next example. Example 4 is kind of interesting. It says square root of 27 is between which 2 integers? So this is sort of an interesting question. Turns out it's pretty easy to figure this out. So write this down and think about how you could figure out. By the way, what are integers? Integers are numbers like what? Integers, guys. 1, 2, 3, 4, 5, 0, and all the negatives. Negative 1, negative 2. None of the, right? No fractions, no decimals, right? Remember integers. So which 2 integers is the square root of 27 in? Okay, so how would you figure this out as you write this down? Think about it. Some of you already know, but yeah, it's pretty straightforward. But think about this. I'll wait. How many people already know the answer? Which integers is this between? Stephanie, what'd you get? 5 and 6 is correct. How do we know that square root of 27 is between 5 and 6? Because, you know, it's kind of nice to know what square root of 27 really is, right? It's between 5 and 6. How do we know that this is between 5 and 6? Yes?
Because the square root of 5 is 25 and the square root of 6 is 36.
Ria is correct. So we know it's between 5 and 6 because we know that square root of 5 is 25, right? Square root of 6 is what? 6 is square root of 36. Does that make sense? So is square root of 27 closer to 5 or closer to 6? Closer to 5, right? So yeah, it's a little bit closer to 5 than 6. Isn't that right? This is, right, square root of 25, square root of 26, and so on. Does that make sense? So when they ask you something like this, all you have to do is look at the perfect squares of the square root and so forth. Because 5 is really square root of 5, right? 6 is really square root of 36. All right, so that's the idea. So when they ask you something like this for your homework tonight, you know how to do it. Okay, let's move on to example 5. By the way, I even have a number line, right? There's 5 and 6. Square root of 27 is right between 5 and 6. No, I'm just showing you that, you know, if you were to, that's where square root of 27 is, right? Just like, where is pi? That 3.14 and so forth. Which 2 integers is that number between? Pi. Between 3 and 4, right? It's between, right? Isn't that between 3 and 4? Closer to 3, of course. Anyway, let's look at example 5 now. Here we go. Here's example 5. It says to simplify this. Square root of 2 over square root of 3. Okay. And this is where we need that sort of a fact about simplifying square roots. Okay. You guys remember? Okay, well, what would you do if I ask you to simplify this? Well, don't you just get square root of 2 over? 3. Is it square root of 2 over 3?
I thought you said that no square roots.
Exactly right. So could I leave it? Whoops. So remember, we cannot have any square roots in the denominator. So could I leave it this way? No. Okay. And so what do I do? Because this is what it means, right? Square root of 2 over 3 is really square root of 2 over square root of 3. We got really a square root on the denominator. We don't want that. That's not how we simplify. Is there a nice way to get rid of this square root in the denominator? Nor?
You multiply by the square root of square.
Yeah, exactly. Turns out all you have to do is multiply top and bottom by that denominator. Square root of 3 times square root of 3. Why do you think I do this? By the way, what is square root of 3 over square root of 3? 1. So I'm really multiplying this fraction by 1. So does it change its value? No, it stays the same. But why did I choose to multiply top and bottom by the denominator, square root of 3 over square root of 3? Why not square root of 5 or square root of 6? Where did I get square root of 3 from? Why do you think I'm doing this? Anybody see why? Yes?
So it cancels out.
Yeah, so it cancels out the square root. Isn't that right? Because what do you get when you do this? Well, isn't this simply square root of 6 over square root of 3 squared? And what does square root and the square do? They cancel each other out, right? So that's why I chose the same denominator.
Like 3 and square root of 6.
Yeah, so this becomes square root of 6 over 3, right? And look at my denominator. My denominator is not a square root anymore. You see? So that's how you simplify square roots like this. I get square root of 6 over 3, like that. Okay? Does that make sense?
Yep.
Easy enough? Okay, so whenever you deal with square roots, you may not have denominator as a square root. And there's nice simple way to get rid of it. Just multiply numerator and the denominator by that square root. Okay, so write that down. Alright, so let's try this one. Square root of 9 over square root of 8. I'm going to put a star on this one because you'll see why in a minute. Okay, so square root of 9 over square root of 8. So what do we do for this? Well, again, we have a square root on the denominator, don't we? Got square root of 8. So what do we get? Well, let's just write down what we get. We get square root of 9 over... Oops, let me try to hide this. Hold on, give me a sec. Okay, so we get square root of 9 over square root of 8. That's simply square root of 9. What is square root of 9? 3. So that's 3 over square root of 8, right? So let's write that down. So we got 3 over square root of 8, okay? Because square root of 9, again, is square root of 3 squared, right? Now, am I going to multiply top and bottom by square root of 8? By square root of 8?
Yes.
You could do that, but you should always, what? Always simplify. What's square root of 8, guys? So before you do that, you should always simplify. So you shouldn't just blindly multiply top and bottom by the square root of the denominator. What is square root of 8? So everybody go ahead, figure it out. Square root of 8, you gotta simplify that first. Then you could get rid of the square root. Okay, so I'll wait. Go ahead, everybody try. Alright, so when you do, did you all get square root of 8? What's square root of 8? That simply becomes, did you all get 2 times 2 times 2? So what's that equal to? 2, I even wrote it out. Square root of 2 times square root of 2 squared times square root of 2. So it becomes square root of 3 over 2 rad 2. Isn't that what we get? So after you simplify, that's when you get rid of the square root. Okay, so don't just try to get rid of the denominator before you're simplifying the square root. Because if you do, it gets a lot more complicated than it should. Okay, so you want to always simplify. Remember, I told you, always simplify. So you want to simplify square root of 8, it becomes 2 rad 2. Now, what are you going to multiply top and bottom by? To get rid of the square root of 2, multiply top and bottom by square root of 2 over square root of 2. Okay, go ahead, everybody try, see what you get. I'll wait. Okay. Okay, so did you all get 3 rad 2 over 2 times 2?
Yeah.
Okay, so what's the answer?
3 rad 2 over 4.
Yeah, 3 rad 2 over 4. Easy enough?
Yeah.
Okay. So you should always simplify, okay, before you do anything. It's going to help you a lot. Okay. All right. Does that make sense? May I move on? Okay. All right. So what about this? I get 3 rad 8 over 8. It says to simplify this. You may say, wait a minute. Is there anything to simplify? I got my denominator is a integer, so that's good. What's there to simplify? Somebody said it? Who's got the idea? The square root of 8. Is that simplified? No. So go ahead, everybody. So sometimes, you get square root of 8, something like that. You should always simplify, right? Go ahead, everybody try, see what you get. I'll wait. Okay, so yeah, it looks like it's already simplified. It's not really simplified. You don't want to leave your answer like this on your test. Then you will not get full credit because it's not simplified, right? Because square root of 8 could be simplified more further. Go ahead, everybody try. I'll wait. Okay, so how many people got 8, of course, when you got to simplify that, right? So you get 2 times 2 times 2. So did you all group it by 2s like this? Thank you. So we get 3 times 2 times rad 2 over 8, right? So what's 3 times 2? 3 times 2 is 6. So we get 6 rad 2 over 8. We're done, right? How many people finished here? Are we done? Not quite. That's why there's a star. Well, how come we're not done here? Why not? Tegan, why aren't we done here?
You're not done because you couldn't simplify the fraction.
Yeah, because you have 6 Really, doesn't this really mean 6 over 8 times rad 2 over 1, if you want to think about it that way?
Yep.
Isn't that what it is, right? 6 rad 2 over 8 is 6 over 8 times rad 2 over 1. What is 6 over 8, class? 3 over 4. So this is really 3 over 4 times rad 2 over 1. So that's why the answer is 3 rad 2 over 4. How many people got this answer? Raise your hand. Okay, does this make sense? Okay, so please be careful. Even though it looks very simple, that's what we get. By the way, okay, so can you do something like this? By the way, can I cancel out 2 and 4? Can I like divide top and bottom by 2 and 2? Doesn't 2 go into 4? Can I do that? No, because 2 is in the square root, okay? So you cannot cancel those out. You can only cancel out with the ones that are integers. Does that make sense? Any question? Could I have canceled out 2 and 8 from the top here? Since these are factors. They're factors, aren't they? 2 is a factor? Yes, you could have. You could have canceled out 2 and 8. You get 2 goes into 8 4 times, right? So you just get 3 rad 2 over 4. So you could have canceled out 2 and 8 up here if you wanted to. Does that make sense? No matter what, you get the same answer. Any question? Can you do something like this for your homework tonight?
Yeah.
Good.